In these examples, I'll do two examples at once. They're very quick, that's why. So in this example, we want to find the derivative of the function g. G is defined as the integral from 0 to x of sine squared of t dt. So you integrate the sine squared from 0 to x, and then you get the function g of x, because when x changes, the value changes. That's why it's a function of x. And they want us to find g prime of x. So one thing we remember is from the fundamental theorem of calculus 1, if you differentiate the integral from a to x of f of t dt, it gives you just f of x. That's the result of this fundamental theorem of calculus. That's what it says, okay? So in this case, the derivative of g is simply the derivative of from 0 to x sine squared of t dt. So simply applying the theorem, this gives us sine squared of x, and that's it. That's the derivative of the function g of x. In this one, I have g of x as the integral from x to 1 of cosine of cubed of t dt. Well, here x is in the wrong place. If you look at the theorem, x has to be the upper limit of the integral. Okay, x has to be the upper limit of the integral. So x is in the wrong place in the second example. So we have to somehow adjust our function, so that x is on top. So one of the properties of the definite integral is if you swap the limits, then it costs you a minus. So this is exactly minus integral from 1 to x of cosine cubed of t dt. Now x is in the right place. I can differentiate this function. So g prime of x is the negative of cosine cubed of x, and that's the answer.